Hi, everybody, and welcome to our lesson 3. Our lesson 3 is on volume. So what volume is a 3D space that's occupied by a figure. So the main things that we're going to be looking at are prisms, right? And prisms are 3D objects with two identical bases. So what does that mean? Okay, so if we take a look at our figure here, right, the base on the bottom here, the bottom of the Chips Ahoy box, that base is also going to be the same as this base up top, right? So that has two identical bases. So the common prisms that we're going to see are rectangular prisms. So what I just showed you here with the Chips Ahoy cookie box, or I guess cereal box, are triangular prisms. So like our Toblerone box here, right? So the bases are, we have a base here and the identical base on the other side. And then we're also going to be looking at cylinders. So cylinders are like cans, paper tubes. I can even think of something else right now, but these have bases that are similar here and a base on the bottom, right? So the circular top is the same as the circular bottom. So the formula for these prisms is the area of the base, right? So if we were taking a look at this soup can, the area of the base. So in our last lesson, 2 lessons ago, actually, we found out how to figure out the area of something. So we would figure out the area of this circle, right? The circle on the top. And then we would multiply it by how high this soup can is. Okay, same thing for the rest of them. So our box, we would take the area of the main base here, right? So the bottom of the box, as we can see it up here. So we would take the area of that, and then we would times it by how tall this is. When we take a look at triangular prisms, right, our base is these two here, right? So we would find the area of this base here, and then we're going to times it by how it looks like how long, but this would be how tall it is as well. So the area of the base times by the height, okay? So for cylinders, the form just looks a little bit different, right? Because our area of the base would be the pi r squared, and then you would just multiply it by the height. So let's get into some examples. I'm just going to change this so we actually have a pen versus me trying to erase things that are not there. Okay, so determine the volume of this box. So when we find the volume of the box, we need to find the area of the base first, right? So I'm just going to write down the volume equation. So I have volume equals the area of our base, right? So the area of our base is always length times width for a rectangle. And then we're going to times this by our height, right? And so remember what I always like to do. I always like to write my knowns and my unknowns. So what are we looking for right now? We're looking for the volume. So my volume is a question mark, right? And then my length would be my 25 centimeters. So I would put 25 centimeters. My width is this 10 centimeters here, right? So then I would say it's 10 centimeters. And my height is this 40 centimeters tall. So I say H equals 40 centimeters. Right, and then I just take my information that I have there and I plug it into my equation. So I would go my volume equals my length, which is 25 centimeters, times my width, which is 10 centimeters, times by my height, which is 40 centimeters. Right, so I just put that into my calculator. So 25 times 10 times 40, right, which is going to give me 2,500. And my units would be in units squared, right? Because we have 3 centimeters here and they're being multiplied. So I would have my centimeters, or sorry, not squared, cubed. Okay. And that would be the area of my box. Okay. So we're going to do a few more, if it'll let me go to the next one. So determine the volume. We have 3 figures here, right? So to determine the volume of a triangular prism, right, we are going to take the volume of our base, right? So the volume of our base, right? Oh, I don't like the look of that one. Volume of our base, or not our base, sorry, the volume, the area of our base, right? So that's the area of our base. We would do for a triangle, it's always base times height divided by 2, right? And then we would multiply it by, this would be our quote unquote height. So we're just going to put an L because at that point it kind of looks like a length. So then I would write my knowns and my unknowns. So my base is 1.5 meters. So I would put 1.5 meters. And then my height is my, right here, 0.6 meters. And my length, or I guess this could be still how tall, would be 8 meters. Okay, so then we take this information and we plug it into our equation. So we go, our volume equals my base, which is 1.5, times my height, which is 0.6, and then divided by 2. I'm going to put the rest in brackets, times my 8 meters. Now remember, this is all in meters. I should have put the units afterwards, but it did not. So then we get the 1.5 times 0.6 divided by 2, right? If you put that in your calculator, you're going to get 0.45 meters squared times 8, and then meters. Okay, and then we get 0.45 meters squared times 8 meters, and that's going to give me 0.6 meters cubed. Okay, and that right there, guys, is my volume. And then the next one we're going to go to is our cylinder. So I would write the same thing. I would do my equation equals volume, and then I believe it was pi r squared, right? Because that is our area of the base. And then we would times it by how tall this is. So the height. So then I would write my knowns and my unknowns. So my v, I don't know. My pi, we already know it's 3.14, and a bunch of other numbers. My radius, right? So radius is from the center point to the outside of the circle. And right now we know what the diameter is. And the diameter means that it's all the way across, right? So if we have 3 inches all the way across, what we have to do is divide it by 2. So what that is going to give me, right? So 3 divided by 2 is going to give me 1.5 inches. Right, so my radius, therefore my radius is 1.5 inches. So 1.5 inches. And then my height is 1.25 inches. And then I just take that information and I plug it into my equation. So I have my volume, we don't know, my pi, and then my r is 1.5, and I square that times h. Right, and then I plug that into my calculator and I get 7.0, 7.07 inches squared times, right, I only did what's inside the brackets, times 1.25 inches. Which allows me to get the volume. If I multiply these two together, I get the volume of the cylinder, and my volume is 8.84 inches, and then it would be in cubes, right? Because I get 2 inches here, or inches squared here, times another inch is going to give me inches cubed. And then I would box my answer for this one too. And then, I got it wrong one. We're going to take a look at, I'm just going to hide this. We're going to take a look at how to find the volume of a composite figure, right? So composite figures, we learned how to find the area of composite figures in the previous lesson. So we're doing very similar things for finding volume. So what I would do, right, our step one was to always break it up into figures that we already know how to deal with. So what I would do is I would cut this down here and deal with two different rectangular prisms. Okay, so I would label this as number one, and this is number two. So when I cut this here, right, I would then get 13 minus 4, right, which is going to give me 9. So this remaining on this side is 9 inches, right, because I have to get rid of 4 because I cut it right here. And if 4 inches is on this side, 4 inches has to be on this side, and it has to be on this side. Therefore, I would do 13 minus 4 to get my 9 inches from here to here. Okay? So then I would find the volume of my first object, right? So I would do a number 1. And I would find the volume of a rectangular prism by doing volume equals, and then my area of my base, so length times width, and then times height. And then I would put my known and unknown information. So volume we don't know. My length is going to be this here, right? So my length is 4 inches. My width is this here, right? So I have 11 inches. And my height is the same as over here, right? Because it would be the same all the way across. So it's 4 inches here. Perfect. And then I just take that information and plug it into my equation. So I have my volume, which I don't know, my length, which is 4, times my width, which is 11, and then times my height, which is also 4. And guys, remember to put, I forgot to put inches afterwards. And then so I do 4 times 11 times 4, which is going to give me 176 inches, and then it would be cubed. And I found the volume for my first part of my figure. And then, a little bit longer, I'm going to take a look at the second figure, right? The second one I cut up. So I have for number 2, I'm going to do the same thing, right? So my volume, I'm going to do length times width, because that's the area of my base, and then times height. So then I have, erase you. Yep, no, volume equals question mark. My length is going to be 9 inches. My width is going to be that 7 inches, right? So this would be my width on the same on the bottom. And my height, right, it's still 4 inches. So my height is 4 inches. And then I take all that information and plug it into my equation. So my volume equals my length, which is 9, times my width, which is 7, and then I times it by my height, which is 4. And then the volume that I get is 252, and then my units are still in inches cubed. Perfect. So I've cut this up into things I already know how to deal with, and then I have found the volume for each of those figures, right? So for each of those rectangular prisms. Now my third step is because it's together, I now add these volumes together, right? So I'm going to go for my step 3, which is to add them together. So my volume total equals the volume, I'm just going to do tiny little squares, plus the volume of my other one. So the volume of the first rectangular prism plus the volume of the second rectangular prism. We'll just do 1 and 2. Perfect. So my total volume equals volume 1, which is 1.7. Oh, that's not a point. So 176 inches cubed plus my 252 inches cubed, which is going to give me a total of 428 inches cubed. And I box that, and that's the total volume of my figure here. Okay, so we have a couple more questions to go through, and then I will assign you guys your homework. So this one's a word problem. So a rectangular swimming pool holds 2,000 liters of water. The pool is 14 meters long and 6 meters wide. So how deep is the pool? So what I would do first of all, if it's a word problem and I don't have a diagram, is I would draw my diagram. Okay, so we have our diagram drawn here. So we know that the length is 14 meters, right? So I would do my length is equal to 14 meters. And my height, I don't know, right? Because that's what they're asking for. My width is 6 meters. And then I have a volume. So one thing about this volume right now is it's in liters, right? So we need it in meters cubed because these are both in meters. So what we need to do, first of all, is I'm just going to put my volume equals 200,000 liters. I don't even know if I said that properly the first time. But we need this to be in meters cubed. So the first thing that we need to do after our diagram is drawn is to convert this into meters cubed. Okay, so the conversion that I have here is that for every 1 liter, it equals 0.001 meter cubed. Okay, so that's our conversion. So we now need to convert our volume in liters into meters cubed because we need to find the height in meters. Okay, so remember for our conversions, we set it up all the same. I would take I'm just going to put a little one, 200,000 in liters, and then I would do my times, and then I would have my conversion. So we need what we want on the top, right? And so we want these meters cubed. So I would put 0.001 meters cubed on top and my 1 liter on the bottom. And then I have my equal sign. So I would do 200,000 times 0.001 meters cubed divided by 1 liter. So then my liters cross out and I end up with 200 meters cubed. Okay, so that is now my volume. Okay, so now what I can do is plug all of that information back into my volume equation for a cube, right? And so the equation for this, again, we've been using it all through, my volume equals my area of the base, so my length times my width, and then I times my height, right? And I have all this information already that I can plug right into it. So my volume is now 200 meters cubed, which equals, and then my length is, we're going to bracket, 14 meters times my width is 6 meters times my height. Okay, and so I get, let me just extend the page a little bit. So then I get 200 meters cubed, and then 14 times 6, which gives me 84. And this would be in meters squared, right? Because we have a meters times a meters, which is meters squared, and then times height. So for us to get height by itself, because that's what we need to figure out, right? What we have to do is, because it's being multiplied on this side, I now have to divide my 84 meters cubed on this side because right now it's being multiplied. So therefore I have to divide it on this side. So then I would divide by 84 meters, squared. Okay, and then this cancels out, right, because it would just be a 1. And then I get 200 meters cubed divided by 84 meters squared. Okay, let me just change this back. Perfect, so 200 meters cubed divided by 84 meters squared is going to give me 2.4 meters equals height, right? Because we have 3 meters up top, we're being divided by 2 meters on the bottom, so therefore we only have 1 meter left, right? So I have 2.4 meters is my height. And the question, because it's a word question, I now have to finish off with a therefore statement. So the pool is 14 meters long and 6 meters wide. How deep is the pool? So then therefore, so I'll just do a number 3. Therefore, the pool is 2.4 meters deep. And that's it. So 2 more quick questions to go over, and then I will assign your homework. So what happens if we're given the volume and we're looking for the height? We kind of did something, we actually did the exact same thing here, right? We just don't have to convert the volume for this one. So we're going to do the exact same steps we took on the other side. Just to kind of hammer this into your head. We have our volume is given to us. We don't know our height. We know that my length, I'm just going to add on to this one. My length is my 7. My width is my 8. Right, and I'm going to plug that into my equation. So my equation is volume equals bracket length times width times height, which equals 7 times 8 times height we don't know, and my volume is 280. So then I do 280, and my 7 times 8 is going to give me, I believe, 50. Side of this one is going to give me 54, 56. 56. I should know that, but I'm going to use my calculator. So 56 times my height, and then I have my 280 divided by 56, right? Because whatever we do to the right side, we have to do to the left, and we have to divide this by 56 here. Therefore, we have to divide this by 56 here, and we have to divide it on this side because it's being multiplied, right? So then that crosses out. Let me go back to my black pen, and then I do 280 divided by 56, which gives me 5. So 5 equals 8. So my height is 5. Okay, and then we'll head down. We'll do this last one quickly. Okay, so we're looking for the radius of this, this figure. So what I need to do is I need to find my equation for this, right? And my equation is volume equals pi r squared, because that is going to tell me the base, right? This base, this circular shape, oh my goodness, this circle. And then I'm going to times it by my height. So how tall this is. So my R, I don't know, right? My volume is 8,400 and my height is equal to 12. So I take this information and I plug it in here. So my volume is 8,400 and then pi, and my R we don't know, times my height, which is 12. Very bad looking 12 there. So then I would get rid of this 12, right? Because we need to get R alone. So we have to get rid of everything else on this side. So we would do, let me change the color. Both of these would have to be divided by 12 because it's being multiplied. So we have to do the opposite, right? So I divide that side by 12. I divide this side by 12. So I get 700. So I'm going to go back to this. So I have 700 equals pi r squared, because this cancels out. And then I need to get rid of my pi on this side. So I would divide both sides by pi. Right, so divide u by pi. Divide u by pi. And those cancel out. So then I get 700 divided by pi. Let me just flip my calculator here. So 700 divided by pi is going to give me, if I can go back to my other color, 222.82 equals my r squared. And now I need to get rid of this squared. So to get rid of this squared, what I'm going to do, I wonder if it'll, is square root it on both sides, right? So I'm going to square root this side, square root this side, and that's going to get rid of the square on that side. And so 222.82 square rooted is going to give me 14.927 equals r. So my radius is 14.927. And now I have some practice questions for you guys. I do have them on the blank worksheet as well. So if you do not have, like if you do not pause this, you can find them there. So page 23, question number 1, 2, 4, 5, and 8. Okay. If you have any questions, please don't hesitate to ask me. I'm always here if you need me.